All right, here we are, day 2. We're going to throw some variables into the mix now, and we're going to simplify some more radicals. Giddy up. So, I'm breaking this down. Can't take the square root of v. You can always take the square root of v squared, because that's a 2 and that's a 2. So, moving forward, the square root of v squared is v. The square root of v is the square root of v. Now, if you ever have the third root of v squared, can't do it. If this number is bigger than that one, it stays. But if I have something like this, the square root of v to the third, that's a 2 in there. Now, we all agree that 3 is the same thing as 2 plus 1, right? Okay. So then we break this down into something that can be taken out and something that can't. So this would be like saying the square root of v squared times the square root of v. All right, so the square root of v squared is v, and the square root of v is the square root of v. So, the square root of v to the third ends up like that. Now I'm going to do several more examples. If that was super confusing, I'm going to try and make it easier. It's going to be okay. So, anyway, we're dealing with square roots here on number 1. So, I'm breaking 12 into 4 times 3. I'm just tacking the v on, because it's there. Why not? So the square root of 4 is 2. That's the only thing in this entire problem that you can take the square root of. That means the 3 and the v stay inside. That's it. I'm going to jump down to number 3 real quick. This one has 2 things that we can take the square root of because we know that 100 is 10 squared and k squared is k squared. So the square root of 10 squared is 10. The square root of 100 is 10. I agree with that. And what's the square root of k squared? Well, it's going to be k. Okay? Yeah. So there's that. All right, so we're done. If you could take the square root of it, it comes out. If you can't, it stays in. So let me come over here. Now, 448 is the same thing as 64 times 7. Yeah, I had to pause the video and work on that. So anyway, 2 to the 6th power. 2 to the 6th power is 64. So I started there. Then I was like, okay, well, if we have to figure out how many times it goes into that. So I said, okay, it was 64 times 7, and then that 3 is less than the 6. So I'm going to leave the p to the third inside this root. Now, 64 is the same thing as 2 to the 6th. So what's the 6th root of 64? 2. Pops out. If you'd rather write that as the 6th root of 2 to the 7, or 2 to the 6th, times 7 times p to the third, then by all means do. But anyway, what happens is this then turns into, I'm going to draw this over here, the 6th root of 2 to the 6th is 2, so 2 pops out, and then everything else stays in, the 6th root of 7p to the third. So this is my completely simplified answer there. Since this number on the p is less than that one, we can't do anything with it. It just doesn't happen, kind of like just up here. Then, moving down here, so 64, I'm talking the 4th root here. So I'm going to remember that 2 to the 4th power is 16, and that 64 is the same thing as 16 times 4. So 16 times 4, and then there's just an m there. Now that's a 1. Since that's less than the 4, we're not really messing with the m very much right now. So 16 is the same thing as 2 to the 4th, and then the 4, and then the m to the 1st. Okay? So the 4th root of 2 to the 4th is 2. So 2 pops out, and then I have the 4th root of 4, because we can't do anything with that, and then m. So if you want to make it look really nice, it would be 2, and then 4th root, 4m. And that's going to be a completely simplified radical there. All right. So, here we go. Square root. So we can take the square root of k squared, so I'm going to leave the k squared there, not mess with it at all. 8 has to break down to 4 times 2. So there are 2 things in here that we can take the square root of, 4 and the k squared. The square root of 4 is 2, so 2 pops out. The square root of k squared is k, but you can't mess with that 2. Can't take the square root of it. So then I leave the root 2 right there. And that's how you simplify that radical. Now, I know that 2 to the 3rd power is equal to 8, so that's where I'm starting right here. I look at the 3rd power right there, the radicand, and I'm like, all right, I got to figure out something that'll go into 32. So luckily on my first guess, found it. So this turns into, I'm leaving the 3 there, 8 times 4 gives me 32, and then there's a v stuck on there. Okay, no big deal. So the third root of 8 is like saying the third root of 2 to the third, and then times, oh, it's not 2, times 4v. So the third root of 2 to the third is 2, so that pops out, and then I'm left with the third root of 4v inside. So that is going to be my simplified radical right there. Next up, I have the square root of 180k squared. Unfortunately, it's not going to be as clean as the 10k that we got in the last 4, but square roots shouldn't be that bad. I am going to pick the largest square that goes into that, and some of you might be thinking 9. No, I'm going to go 36. It's 36 times 5, and then there's a k squared there. With square roots, it should be a little easier for you. The square root of 36 is 6. The square root of k squared is k. And then the square root of 5 is just the square root of 5. So there's that. Okay, you're going to do 8 on your own because it literally has 8 involved. All right, now we're getting to the more difficult ones here. Eventually, now I'm going to go ahead and go right here first. You can do 9 on your own because 90 is the same thing as 49 times 2. Wink, wink, nod, nod. So, square root. So I'm going to look at the 28 first. Now, that's the same thing as 4 times 7. I broke that down because 4 is a square. Now, this is 2 right there, and this is a 4. All right, so it's like taking the square root of n to the 4th. So what it is really is n squared times n squared. If you like looking at it like that better, good. And this is how we're going to break this one down. All right, the square root of 4 is 2. The square root of n squared is n. The square root of this n squared is n. And then I have 7 left inside, so 7 stays there. So for simplifying this and making it look really nice and neat, 2 times n is actually 2n squared. Root 7. So if you want to figure this out, an easier way to do this, when these are divisible, what's 4 divided by 2? 2. That's where that came from. So our final answer is just 2n squared, and then I have root 7 there. All right. Then, all right, number 11, we have 2 variables involved. This is similar to number 1, but just a little bit different, I guess. Now it's square root, so 4 times 3, and then I have m. Now, this n to the third, there's a 2 in here. There's an n to the third. So I'm going to break this n to the third into n squared times n. Once again, because 2 plus 1 is 3. So I didn't change it. I just changed how it looked. Okay, I did that because now, since there's a magical little 2 in there, we can take the square root of some things. The square root of 4 is 2. Can you take the square root of 3? No. Can you take the square root of m? No. Can you take the square root of n squared? Yes. The square root of n squared is n. So n pops out as well. Can you take the square root of n? No. So we have some things that popped out. We had 2 and an n from there, but we're left with a 3mn from here, here, and there inside. So then that's your simplified radical there. All right. We can get one more problem in here. Now we're talking the 4th root, so we have to break this thing down and make it look good to us first. Now, since it's 4th power and that's an odd number, I'm going to start thinking, okay, well, 3 to the 4th power is 81. I'm remembering that from our previous assignment, okay, or that table that I attached. So, how many times does 81 go into 567? Well, I'm doing the math in my head, or not really, I just did it in the calculator. 7 goes in 7 times. Okay, so that's helpful, all right, because this is the same thing as the 4th root of 3 to the 4th times 7. Okay, now there's an x. Unfortunately, we're not going to be able to do anything with that one. But this y to the 6th, we can break that down. Now, 6 is the same thing as 5 plus 1, 4 plus 2, 3 plus 3, 2 plus 4, 1 plus 5. So I'm going to break this down to y to the 4th and y squared. Y to the 4, because 4 is going to work with that. So now I'm just going to recopy everything, make sure everything is in order. And I had to have this 2 there because 4 plus 2 gives me 6. That's what I needed. So now I'm going to start taking the 4th root. The 4th root of 3 to the 4th is 3. Can't do that, can't do that. The 4th root of y to the 4th is y. Can't do that. So what we have now is 3y, and then I have the 4th root of 7 stayed in, x stayed in, and this y squared stayed in as well. I'm going to clean that up a little bit. Just like that. I'm going to put a box around it, and you'll hear from me on the next video. Thanks.